Okay, so we're gonna do some problem solving in preparation for the midterm, and we're gonna focus on three main topics: statistics, modeling, and simulation. Okay, so let's look at the first problem. This is not moving, is it? So, an engineer investigates the void ratio of compacted asphalt samples from 5 different batches. The measurements as a percentage are sample A 6.3, sample B 5.9, sample C 6.1, sample D 5.6, and E 6.4. So we need to calculate the mean and the median, and then the standard deviation, and then CV. And then, as student suggests, the air void content may be affected by compaction temperature. What statistical method would best test this out for us, right? So we're gonna look on how to handle and solve these three. Now we need to enable the pen. I'm not seeing its enablement, and here we go. Okay. So number one, we want to calculate x bar, which is equal to, we simply sum all our options 5.6, 6.4 over the total number of samples, which is 5, we get 6.06. So this is my x bar. And then the second part is the median, which is equal to, first we need to sort. So 5.6 is the smallest, followed by 5.9, followed by 6.1, followed by 6.3, and then 6.4. And by definition, the median is the center of the data set, and the data set is odd. So we have 1, 2, 3, 4, and 5. So technically, it is in the middle position, which implies the median is 6.1. Now, question 2 for... Now we move on to calculate the standard deviation, S or sigma, whatever name you would like to have for it, which is the square root of xi, so each instance of x minus x bar over n, right? So the square root of xi minus x bar square over n, which is equal to 5.6 minus 6.1 square plus 5.9 minus 6.1 square, and so on over 5, right? Square root. We get, which will be equal to 0.287. Now, from here, we can answer part 3, where we get CV, which is standard deviation over x bar. So 0.287 over 6.06, we get 4.74%. Now, as for the final part 4, the question is, what is the best method to figure out the relationship between two things? And generally is correlation, right? Correlation, and therefore the other way around is also regression, but it's, in the modeling chapter, and therefore by association for regression are squared. So any conversation, any explanation that involves, these three somehow should be a good answer. Now, moving on to modeling, we're given a certain data set that looks like this. So we have a table, we have multiple rows, we have the X, which is the age, and then we have the maintenance cost in dollars, right? And thousands of dollars. And we want to figure out an equation that represents them. And as I said, like generally the first step is summing the X and the Y. So having the summation of X and Y, which in this case it's 2 plus 4. So we have 6 plus 5, 11 plus 7, 18 plus 9. We have 27 here, right? And here we have the summation of Y, which is 5.1 plus 8.3 plus 10.1 plus 13.8 plus 16.4, which should be, so 13.4, 23.5, 36, 37.3, and then plus 1, 47, 53, I think it's 54.2, give or take. And then we divide each of those numbers, and so we want their averages. We want the X bar and the Y bar. So X bar and Y bar will be equal to this summation over 5 over the total. So we get here 5.4, and Y bar we get 10.74. So we calculated those, and then we need to calculate X minus X bar, X minus X bar, X minus X bar times Y minus Y bar, Y minus Y bar, and X minus X squared. So we continue building the table, right? So what is X minus X bar? It is 2 minus the 5.4 that we got for each one of those. And then we lay out the results in a new column. So minus 3.4, minus 1.4. Then we have minus 0.4, 1.6, and 3.6. And this is X minus X bar. Same thing for Y, minus 10.74. For all the elements, we would get Y minus Y bar, which is minus 5.64, followed by minus 2.44, followed by minus 0.64, followed by 3.06, and 5.66. The next step is multiplying these two. So X minus X bar times Y minus Y bar, we get 19.176, and then 3.416, and 0.256, 4.896, and finally 20.376. Finally, we square this one, square. So we get X minus X bar square, which is 11.56, 1.96, 0.16, 2.56, and 12.96. We move on to calculate the slope and the intercept. So this finishes part 2, right? This is part 2. Now we need to calculate the slope and the intercept. The slope, in this case, given here, it is m. So whatever is multiplying the x, the equation for it would be m here is 48.12 over 29.2, which is, in this case, sigma x minus x bar into y minus y bar over what? Sigma x minus x bar square. Now we apply the equation for B, which is in your notes 8. Like, why did I switch them around? To remind you that the intercept, the one that is not multiplying the x, we can call it whatever we want, but we apply its equation, and the one that is multiplying the x will have the equation fixed x minus x bar over y minus y bar over x minus x bar squared. So we plug in the m into the equation of A, and we get B is equal to 1.862. So the final equation would be y equals 1.65x plus 1.86. This is my final product. Now moving on to the final problem in simulation, compute the demand and capacity. Simply, we're given two random numbers and two equations. We plug them into the equation. So demand, it's going to be 250 plus R1 times 50, which means in this case 250 plus 50 times 0.78. It gives me 289 liters per minute. And the second one is 270 plus 40 times 0.45. So we get 288 liters per minute. So this is the demand and the capacity. This is demand and this is capacity. The second question, determine if the system fails, right? So since demand is greater than capacity, even by 1, implies fail. The system has failed in this iteration of the simulation. And as you know, we repeat these as many times as humanly possible until we reach a state of convergence. So initially with each trial, there will be high bias and lots of changes, but over time it will normalize and become a straight line. So once it starts converging like this, we stop the simulation. And that's the purpose of it, really, because the possibilities are infinite. So we would need something that gets us close to reality as fast as possible. So these are the main ideas in statistics, modeling, and simulation. So practice them, make sure you understand everything that is included in them, and you should be more than fine. Best of luck.